Learning objectives. At the end of this topic, you will be able to measure the volumes of the following 3D shapes: cuboids and cubes, cylinder, right circular cone, and sphere. Before going in depth into this lesson, let's recall what is volume and what is capacity of the container. The dimensions of a cube or a cuboid are length, breadth, and height. What's the difference between cube and cuboid? Yes, all the sides of a cube are of equal length. Do you still remember the meaning of volume? The volume of an object is the amount of space it takes up. On the other hand, if the object is hollow, then the interior is empty, and it can be filled with air or some liquid that will take the shape of the container. The volume of a container is generally understood to be the capacity of the container. That is, the amount of fluid, gas or liquid, that the container could hold, rather than the amount of space the container itself displaces. In short, the volume of an object is the measure of the space it occupies, and the capacity of an object is the volume of substance its interior can accommodate. Hence, the unit of measurement of either of the two is cubic unit. Children, here are some containers which are related to shapes of squares and rectangles. I want you to measure the dimensions and calculate the volume of these containers, then record your findings in the table. Remember, the dimensions are the length, the breadth, and the height. The standard unit for volume is the cubic meter. A smaller unit for the volume is the cubic centimeter. The symbol stands for cubic meter, and the symbol stands for cubic centimeter. You can sit in groups of 3 and do the activity. Any more questions, children? No, teacher. You can start now. Okay. Let's measure and record the dimensions of these solid cubes and cuboids and calculate the volume.
Anu, we will use this ruler to measure the containers. Let me measure. You will record the measurement in the table. All right, let's start now. Container A has the shape of a cube. The length is 2 centimeters. The breadth is 2 centimeters and the height is 2 centimeters. To find the volume, we have to multiply the length, the breadth, and the height. That gives 2 centimeters times 2 centimeters times 2 centimeters. That will give us 8 cubic centimeters. This container B has the shape of a cuboid. The length is 6 centimeters. The breadth is 1 centimeter and the height is 2 centimeters. Okay, I've recorded all the measurements. Now let's find the volume. 6 centimeter times 1 centimeter times 2 centimeter is 12 cubic centimeters. This is easy, Rita. I think we can finish all these containers and boxes within an hour. Yes, Anu. Now let's continue with the work.
Let us count the unit cube to get the volume. Look at this big cube. It's made up of 27 1 centimeter cubes. The length is 3 centimeters, the breadth is 3 centimeters, and the height is 3 centimeters. What is the volume? The volume is the length times the breadth times the height. That is, 3 centimeters times 3 centimeters times 3 centimeters equal to 27 cubic centimeters. Do you know how to find one of the dimensions? If you're given the volume and other 2 dimensions. Let me show you one example. To find the length, you have to divide the volume by the other 2 dimensions. So, 27 over 3 times 3 will give you 27 over 9. 27 divided by 9 will give you 3. Count and calculate the cuboid with the unit cube. This cuboid is made of 36 1 centimeter cubes. This cuboid has the length of 6 centimeters, the height of 2 centimeters, and the volume of 36 cubic centimeter. How do we find the breadth? Do you remember earlier how we found the length? Yes, to find one dimension, we have to divide the volume by other 2 dimensions. So, 36 over 6 times 2 will give us 36 over 12. 36 divided by 12 will give us 3. So, the breadth is 3 centimeters. Cinderella is given a rectangular tank measuring 28 centimeters by 15 centimeters by 20 centimeters, which contains 6,000 cubic centimeter of water. She must find out how much more water can the tank hold. Let's help her to find out the answer. What is the shape of the tank? Yes, the tank is the shape of the cuboid, and it measures 28 centimeters by 15 centimeters by 20 centimeters. What is the volume of the tank? Can you find the answer? Good. The volume of the tank is 8 and 400 cubic centimeters. What is the volume of the water in the tank? Good. It contains 6,000 cubic centimeters of water. How much more water can the tank hold? Can you find the keywords here? Yes, the keywords are how much more. What operation should you use? Yes, subtraction. To find out how much water can the tank hold, subtract 6,000 cubic centimeters from 8,400 cubic centimeters. What is your answer? Good. The answer is 2,400 cubic centimeters. The tank can hold 2,400 cubic centimeters more water. Now Cinderella wants to pour half the water into 8 identical containers. What's the volume of water in each container? Let's find out. What is the volume of water in the tank? Yes, the volume of water in the tank is 6,000 cubic centimeters. How much is half of 6,000? Good. It's 3,000 cubic centimeter. How many containers are there to be filled? Exactly. There are 8 containers to be filled. What operation should you use? Yes, division. They are 3,000 cubic centimeters of water to be filled into 8 containers. So we divide 3,000 by 8. What is your answer? Yes, the answer is 375. So the volume of water in each container is 375 cubic centimeters. Look at this question. A cuboid measuring 3 centimeters by 4 centimeters by 8 centimeter is cut from a block with sides of length 15 centimeters. What's the volume of the remaining block? Firstly, try to understand the problem. Do you know the dimensions of the block? Yes, the dimensions of the block are 15 centimeters by 15 centimeters by 15 centimeters. What is the shape of the block? Good, the block is in the shape of a cube. What's the volume of the block? Yes, 3,375 cubic centimeters. A smaller cuboid is cut out from the block. What are the dimensions of the cuboid? Yes, the dimensions of the cuboid are 3 centimeter by 4 centimeter by 8 centimeters. Now find the volume of the cutout cuboid. The volume of the cuboid is 96 cubic centimeters. How do you find the volume of the remaining block? Good. To find the volume of the remaining block, minus 96 cubic centimeters from 3,375 cubic centimeters. What is your answer? Yes, the volume of the remaining block is 3,279 cubic centimeters. You can check the answer by totaling up the volumes of the remaining block and the cutout cuboid. What is the volume of the remaining block? Yes, the volume of the remaining block is 3,279 cubic centimeters. What is the volume of the cutout cuboid? Yes, the volume of the cuboid is 96 cubic centimeters. So, the total volume is 3,375 cubic centimeters. Volume of a cylinder. How much ghee can this container hold? The volume is nothing but how much space takes up the inside of a container. This container looks like the shape of a cylinder. So the volume of a cylinder can be obtained as base area multiplied by height. Here the base area of the cylinder is the circular base. We know the area of a circle is pi r square, which is equal to area of base of a cylinder. Therefore, volume of the cylinder is equal to pi r square h, where r is the base radius and h is the height of the cylinder. Now consider an example. A rectangular piece of paper of width 15 centimeters and length 44 centimeter is rolled along its width to form a cylinder. What's the volume of the cylinder so formed? The length of the rectangle becomes the circumference of the base of the cylinder. 2 pi r is equal to 44. R is the radius of the circle. To find r, substitute the value of pi and simplify. We get the radius of the cylinder is equal to 7 centimeters. The width of the rectangle becomes the height of the cylinder, that is, h is equal to 15 centimeter. Therefore, volume of the cylinder is equal to pi r square h. Substitute the value of pi r and h, we get the volume of the cylinder is equal to 2,310 cubic centimeter. Volume of a right circular cone. Now let's see how the volume of a cone is calculated. Consider a cylinder and 3 cones. 3 cones are completely filled with liquid. Let's empty the liquid into the cylinder. The radius and height of both the cylinder and the cone are the same. The entire content of 3 cones can be emptied into the cylinder. This means volume of the cylinder is equal to 3 times the volume of the cone. Thus, the volume of the cone is 1/3 the volume of the cylinder, where r is the base radius and h is the height of the cone. Example: find the volume of the right circular cone with radius 6 cm, height 14 cm. Here r is equal to 6 cm, h is equal to 14 cm. Volume of the right circular cone is equal to 1/3 pi r square h. Substitute the value of pi, r and h, then simplify and we get 528 cubic centimeters. Next example. The height of a cone is 18 centimeters. If its volume is 1884 cubic centimeter, find the radius of the base. Let the radius of the base of the cone be r centimeters. H is equal to 18 centimeters. Volume is equal to 1884 cubic centimeter. This implies 1/3 pi r square h is equal to 1884. Here substitute the value of pi and h, then simplify, we get r squared is equal to 100. Therefore, r is equal to 10 centimeter. Let's see one more example. The height and the slant height of a cone are 21 centimeter and 14 centimeter respectively. Find the volume of the cone. Using the formula L square is equal to r square plus h square, we have r is equal to square root of L square minus h square. Substituting the value of h and L, we get square root of 21 square minus 14 square. On simplifying this, we get 7√5. So the volume of the cone is 1/3 pi r square h. Here substitute the value of radius. As we found above, then simplify, we get the volume of cone is equal to 3593.3 cubic centimeter. Next, we learn about the volume of the sphere. What do you mean by the volume of the sphere? The space occupied by the sphere in space is the volume of the sphere. In order to understand the concept of volume better, let's perform an experiment involving 2 balls of different radii. Let's try out an experiment. Here are 2 containers of same size filled with water to the brim. Immersed the red ball completely in the container. As you can see, the water overflows. Let's collect the water and keep it aside. Then immerse the blue ball completely in the other container. Collect the water. Compare the quantity of water displaced in 2 measuring jars. We find that the quantity of water that is in jar B is exactly half the quantity that is in jar A. So we can say that the volume of red ball is half the volume of the blue ball. Now let's find a way to calculate the volume of the sphere mathematically. The mathematical formula to calculate the volume of the sphere is 4/3 pi r cube. If you know the radius of the sphere, we can use this formula to calculate the volume. Then we can calculate the volume of the balls or any sphere without performing any experiment anytime. Now let's calculate the volume of the hemisphere. Since the hemisphere is exactly half of the sphere, it follows directly that the volume is half the volume of the sphere. That is 2/3 pi r cubed, where r is the radius of the hemisphere. Now consider the example. Find the volume of a sphere of radius 10.5 centimeter. Required volume of the sphere is equal to 4/3 pi r cubed. Here we substitute the value of the radius, then simplifying, we get 4,851 cubic centimeter. Now consider another example. The diameter of a metallic ball is 4.8 centimeters. What is the mass of the ball? If the density of the ball is 8.9 grams per centimeter cube. Here, the diameter of the metallic ball is 4.8 centimeters. We know diameter is twice times of radius, so we find radius divide the diameter by 2. So to find the radius, divide the diameter by 2. We get radius is equal to 2.4 centimeter. Therefore, Volume is equal to 4 by 3 pi r cubed, which is equal to 4 by 3 multiplied by 22 by 7 multiplied by 2.4 the whole cubed. On simplifying, we get 57.929 cubic centimeter. Given density is equal to 8.5 gram per cubic centimeter. Mass of the ball is equal to volume multiplied by density. So 57.929 multiplied by 8.5, we get 492.40 approximately. Let's see one more example. A hemispherical bowl has a radius of 4.5 centimeters. What would the volume of water it contain be? The volume of water the bowl can contain is equal to 2 by 3 pi r cube. Here substitute the value of pi and the radius 4.5 centimeter. Now cancel 4.2 by 3 and also cancel another 4.2 by 7. Then multiply all the terms. We get the volume of water the bowl can contain is 155.2 cubic meter. Summary. Let's summarize the topic. Volume of a cuboid is equal to length multiplied by breadth and height. Volume of a cube is equal to h square. Volume of a cylinder is equal to pi r square h. Volume of a cone is equal to 1 by 3 pi r square h. Volume of a sphere of radius r is equal to 4 by 3 pi r cubed. Volume of hemisphere is equal to 2 by 3 pi r cubed.